ABAP on Hana Online Training. Learn and improve your skill with Proexcellency. Introduction to ABAP and SAP HANA. What is ABAP? ABAP, Advanced Business Application Programming, is a high-level programming language developed by SAP, systems, applications, and products for developing business applications in the SAP ecosystem. ABAP is specifically designed to work with SAP's application server and is used primarily to customize and extend SAP solutions according to specific business requirements. It is an integral part of the SAP NetWeaver platform and is widely used in SAP's ERP, Enterprise Resource Planning, systems. What is SAP HANA? SAP HANA is an in-memory, column-oriented, relational database management system, DBMS, developed by SAP. It is designed to handle large volumes of data and process massive amounts of information in real time. Unlike traditional databases that store data on disk, SAP HANA stores data in memory, which significantly improves data processing speed. This enables organizations to run complex analytical queries, perform real-time data analysis, and build applications with enhanced performance and responsiveness. Benefits of integrating ABAP with HANA. Integrating ABAP with SAP HANA brings several advantages, including a. Faster data processing. By leveraging HANA's in-memory capabilities, data processing becomes much faster, leading to improved application performance. B. Real-time analytics. HANA's ability to handle real-time data enables developers to build applications with real-time analytics and reporting features. C. Code pushdown. With HANA's powerful processing capabilities, certain operations can be moved from ABAP to the HANA database, reducing network latency and improving performance. D. Advanced data modeling. HANA's native features, like Core Data Services, CDS, views, allow developers to create complex data models, which can be consumed directly by ABAP programs. E. Simplified architecture. Integrating ABAP with HANA allows developers to simplify data access and retrieval, leading to more efficient and maintainable applications. System requirements for ABAP on HANA development. To develop ABAP applications with HANA integration, you need the following. A. SAP NetWeaver application server for ABAP 7.4 or higher. This forms the basis for ABAP development. B. SAP HANA database. You need access to an SAP HANA database to leverage its in-memory capabilities. C. SAP HANA Studio. The HANA Studio is an integrated development environment, IDE, used for HANA development tasks. D. ABAP Development Tools. ADT. ADT is an Eclipse-based IDE used for ABAP development and is used in conjunction with HANA Studio. E. SAP HANA Client. The HANA Client software needs to be installed on the ABAP server to enable communication with the HANA database. Setting up the development environment. Installing and configuring SAP HANA Studio. SAP HANA Studio is the main development environment for HANA-based projects. To install and configure HANA Studio, you'll typically need to download the necessary software from SAP support portal and follow the installation instructions provided. ABAP Development Tools, ADT, installation. ABAP Development Tools, ADT, is an Eclipse-based plugin that facilitates ABAP development. To install ADT, you'll need to download Eclipse IDE and then add the ADT plugin via the Eclipse Marketplace. Connecting ADT to SAP HANA system. Once both HANA Studio and ADT are installed, you need to configure the connection between them. In HANA Studio, you'll define the connection parameters for your SAP HANA system, and in ADT, you'll create an ABAP project linked to the HANA system. Overview of development tools and perspectives. With the development environment set up, you'll have access to various perspectives and tools, including the HANA Modeler for creating database objects, the ABAP Editor for coding ABAP programs, and the Project Explorer for managing projects and resources. New features and syntax in ABAP for HANA. ABAP Managed Database Procedures, AMDP. ABAP Managed Database Procedures, AMDP, is a feature that allows developers to write database procedures directly in ABAP code. These procedures are executed on the database server rather than in the application server, leading to improved performance by leveraging the processing power of SAP HANA. AMDPs enable code pushdown, which means that certain data-intensive operations can be executed on the database level, reducing network overhead and improving overall application performance. CDS views and annotations. Core Data Services, CDS, views are a key feature in ABAP for HANA development. CDS views allow developers to define data models that are semantically rich and database agnostic. These views can include data from multiple tables, apply joins, and implement complex calculations and aggregations. Annotations are used to enhance the metadata of CDS views, providing additional information for better consumption by front-end applications and other components in the SAP ecosystem. Code pushdown techniques. Code pushdown refers to the practice of moving data processing tasks from the application server to the database server. This technique leverages the capabilities of SAP HANA to process data efficiently, leading to improved performance and reduced latency. Code pushdown techniques include using AMDPs, CDS views, and SQL script for complex calculations, aggregations, and filtering directly on the database. Optimizing ABAP code for SAP HANA. Optimizing ABAP code for SAP HANA involves making adjustments to take advantage of HANA's in-memory processing and parallelism capabilities. This includes avoiding redundant data access, leveraging CDS views for data modeling, using optimized SQL statements, and using built-in HANA functions for calculations. Proper indexing and buffering techniques also play a crucial role in optimizing ABAP code for HANA. Working with Core Data Services, CDS, views. Creating basic CDS views. Creating basic CDS views involves defining data models using CDS syntax in ABAP. These views can be projection views that retrieve data from a single database table or entity views that combine data from multiple tables. Basic CDS views are the foundation for building more complex data models in ABAP for HANA. Adding joins and associations. CDS views allow developers to add joins and associations to combine data from multiple tables. Joins are used to merge data based on common fields, while associations establish relationships between different data entities. This feature enables developers to create comprehensive data models that serve as a basis for analytical and transactional applications. Implementing aggregations and grouping CDS. Views support aggregation functions like sum, count, average, min, and max, which allow developers to perform calculations on data and retrieve aggregated results. Additionally, grouping data enables developers to categorize and summarize information based on specific criteria. Consuming CDS views in ABAP programs. Once CDS views are defined, they can be consumed in ABAP programs for reporting, data processing, and other business logic. ABAP programs can use OpenSQL statements to access data from CDS views and process it in the application layer. ABAP development with SAP HANA tables. Creating in-memory tables. In SAP HANA, tables can be created as in-memory tables, which means the data is stored in the main memory rather than on disk. This allows for faster data access and processing. To create in-memory tables in ABAP, you can use data definition language, DDL, statements in ABAP code or define them as part of CDS views. Population data into HANA tables. Once the in-memory tables are created, you can populate them with data using insert statements in ABAP code. Data can be loaded from other database tables, legacy systems, or external files. For large data sets, you can leverage bulk loading techniques to improve data insertion performance. Reading and modifying HANA table data. To read and modify data in HANA tables from ABAP programs, you can use OpenSQL statements. OpenSQL provides a database-independent way of accessing data, and when used with HANA, it can automatically push certain operations to the database for better performance. For data modification, you can use update, delete, and insert statements. Understanding row and column stores. SAP HANA utilizes both row-based and column-based storage for data. Row store is optimized for transactional processing and handles individual rows efficiently, while column store is designed for analytical processing and offers superior compression and aggregation capabilities. Understanding when to use each storage type is important for optimizing performance in different scenarios. Performance optimization techniques. SQL performance trace and analysis. SQL performance trace and analysis tools in SAP HANA allow developers to identify and analyze performance bottlenecks in SQL queries. This helps in fine-tuning queries and optimizing database access. Developers can use tools like SQL Trace, Plan Visualizer, and SQL Performance Tuning Workbench to monitor and optimize SQL statements. Indexing strategies for HANA database. Proper indexing is crucial for optimizing database performance. SAP HANA supports various types of indexes, such as single-column, multi-column, and full-text indexes. Choosing the right indexes based on the data access patterns can significantly improve query performance. Query performance optimization. Optimizing the performance of ABAP programs with complex queries involves techniques like reducing unnecessary data retrieval, using aggregates and joins efficiently, and avoiding redundant calculations. Code pushdown to AMDPs and CDS views can also improve query performance by leveraging the power of HANA. Buffering and caching mechanisms. To reduce the overhead of repeated database access, ABAP provides buffering and caching mechanisms. Developers can utilize shared memory objects, SMOs, to cache frequently used data in the application server memory. Proper configuration of buffer and cache parameters can lead to improved performance. Advanced topics in ABAP on HANA. Using AMDP with native SQL. AMDP can be used with native SQL to execute complex database operations directly on the HANA database. This enables developers to take advantage of HANA-specific features and optimize performance for data-intensive tasks. Consuming external web services in ABAP. ABAP programs can consume external web services to integrate with external systems and retrieve or send data. This allows for seamless data exchange between SAP systems and other web services. Real-time data replication with SLT. SAP Landscape Transformation, SLT, can be used for real-time data replication from SAP and non-SAP sources to SAP HANA. This enables real-time analytics and reporting on the replicated data. ABAP development with SAP HANA Graph Engine. The SAP HANA Graph Engine allows developers to analyze and process graph-like data structures, enabling complex relationship-based data operations. This can be used to model and analyze social networks, supply chains, and other interconnected data. Debugging and troubleshooting ABAP on HANA. Debugging techniques for HANA-optimized code. When working with HANA-optimized code, traditional debugging techniques may not always be sufficient due to code pushdown and execution on the database server. Debugging tools like the ABAP debugger and SQL trace can still be used, but developers may also need to debug AMDPs and CDS views directly on the database server using tools like the SQL debugger. Understanding how to effectively debug HANA-optimized code is essential for identifying and resolving issues. Performance tuning and query analysis. Performance tuning in ABAP on HANA involves optimizing the execution of SQL queries and minimizing data retrieval overhead. Developers need to analyze query plans, use SQL performance trace and tuning workbench, and consider index optimization to improve query performance. Properly tuned queries can significantly enhance the overall application performance. Common ABAP on HANA errors and solutions. As with any development project, developers may encounter errors specific to ABAP on HANA. Understanding common error scenarios and their solutions is crucial for efficient troubleshooting. Some common errors may involve AMDP errors, SQL-related issues, data inconsistencies, and HANA-specific exceptions. Knowing how to handle these errors will help maintain the stability and reliability of ABAP applications on HANA. Best practices for ABAP on HANA development. Naming conventions and coding standards. Establishing consistent naming conventions and coding standards is essential for maintaining code readability and understandability. Following best practices ensures that the code base is maintainable and easier to collaborate on with other developers. Memory management and data life cycles. Effective memory management is critical for optimizing ABAP programs on HANA. Understanding the life cycle of data in memory and efficiently managing data loads and unloads help in reducing memory consumption and improving performance. Security considerations in HANA-enabled apps. Security is of utmost importance in any application development. ABAP developers working with HANA need to be aware of HANA-specific security considerations, such as SQL injection prevention, data encryption, and user access management. Testing and quality assurance. Thorough testing and quality assurance practices are essential to identify and fix defects before deploying ABAP applications on HANA. Automated testing, unit testing, and performance testing play vital roles in ensuring the reliability and robustness of the developed applications. ABAP on HANA project examples. Building a HANA-backed analytics application. This project example involves developing an analytics application that leverages the power of Hana to process and analyze large datasets in real time. The application could include interactive dashboards, advanced data visualizations, and ad hoc reporting capabilities. Real-time reporting with ABAP and CDS. In this project example, you'll build a real-time reporting solution using ABAP and CDS views. The application fetches real-time data from Hana tables and provides dynamic reporting capabilities with drill-down options, enhancing performance of existing ABAP code. This project example focuses on optimizing existing ABAP code for Hana. You'll identify performance bottlenecks, implement code pushdown techniques, and use CDS views and AMDPs to improve the performance of the application. ABAP on Hana certification preparation. Overview of SAP Hana certification. This section provides an overview of the SAP Hana certification, explaining the topics covered and the importance of the certification for ABAP developers working with Hana. Tips and resources for exam preparation. To help candidates prepare for the certification exam, this section offers tips, study strategies, and a list of recommended resources, including books and online courses. Sample questions and practice exercises. In this section, you'll find sample questions and practice exercises that simulate the format and difficulty level of the actual certification exam. These exercises will help you assess your knowledge and readiness for the test. Conclusion and further learning. Recap of key concepts. The conclusion section provides a summary and recap of the key concepts covered throughout the ABAP on Hana learning journey. Next steps in ABAP on Hana learning journey. For those interested in further learning, this section suggests potential next steps, such as exploring more advanced topics or specialized areas of ABAP and Hana development. Additional resources and references. The final section offers additional resources and references for continuous learning and deepening knowledge in ABAP development with SAP Hana. These resources may include blogs, community forums, SAP official documentation, and more. Why choose Proexcellency for ABAP on Hana Online training? ABAP on Hana is a powerful programming language that can be used to develop and customize SAP applications. If you are looking to learn ABAP on Hana, Proexcellency is a great option. Here are some of the reasons why. Expert instructors. Proexcellency's instructors are all experienced ABAP on Hana professionals with a deep understanding of the language. They are passionate about teaching and will help you to learn ABAP on Hana quickly and effectively. Flexible learning options. Proexcellency offers ABAP on Hana training in a variety of formats, including online, instructor-led, and self-paced. This means that you can choose the format that best suits your needs and learning style. Real-world projects. Proexcellency's ABAP on Hana training includes real-world projects that will give you the opportunity to apply your skills in a practical setting. This will help you to gain hands-on experience and develop your problem-solving skills. Accreditation. Proexcellency's ABAP on Hana training is accredited by SAP, which means that you can be confident that you are learning from the best. In addition to these reasons, Proexcellency also offers a number of other benefits, including 24/7 support. Proexcellency's support team is available 24/7 to answer your questions and help you with your learning. Money-back guarantee. Proexcellency offers a money-back guarantee on all of its courses. This means that you can be confident that you are making a wise investment in your education. If you are looking for a comprehensive and effective ABAP on HANA training program, Proexcellency is the perfect choice. With expert instructors, flexible learning options, real-world projects, and accreditation from SAP, Proexcellency can help you to learn ABAP on HANA and achieve your career goals. Thanks for watching. Connect with us. +918722079509 vertical bar +919008906809 www.proexcellency.com